I know yesterday was like confusing. I think the confusing part of it is this is simplistic, and I'm finding a complex, hard way of trying to like take something simple and explain it. So here's what I did. I changed and I wrote it out this way, and I think it makes a lot more sense and will be a lot more helpful. So the number, to determine if the number is significant, it is significant if the following is true. It's a non-zero digit, so if it's the numbers 1 through 9, it is significant. Then the trick comes with the zeros. So I put in the cases when they're only true. So a zero between non-zero digits, this is the sandwich that I talk about. So sandwich zeros, these are significant. Trailing zeros with a decimal. So if a decimal is present, trailing zeros count. And then lastly, this one, 4, kind of falls in with 3. So, but I put it anyway. Any digit of the number in scientific notation. So the 0 here is significant. It would still be significant under rule 3 because of the decimal point. Okay? You just have to notice and be able to count how many significant digits there are. Okay? What you're going to do with this is numbers that are given to you that you have to use, you have to identify how many significant figures are in it, and then determine how many significant figures are supposed to be in your final answer. And we're going to do this throughout the whole year so that you are prepared and ready on that AP Chem exam. Now, I didn't write it out, I feel like you got it. If we're adding or subtracting, then we go round to the lowest place past the decimal. If we are multiplying or dividing, then we will round to the lowest number of significant figures. I just want to work a couple of those, and then the good news is today we get to get into a review pretty much and get with the real deal material. So we have two situations. So let's say we had something like, so I had these three numbers and we're adding them together. So these three numbers are given to you, we're adding them together. How many significant figures are in these?
4.
There's 4, 2, 4.
So there's 2.
So what place do I round to?
To the 10th place.
To the 10th place. Because this is the one that's going to determine it. That is the lowest value place past the decimal. So the 6.3 determines that we're going to stop in that 10th place. So I really don't need to worry about this 8 at all. So I'll take the 5, take the 7, 8, 9. So I get 19.75, but how many sig figs, how far past the decimal should I go? So the correct answer would be 19.8. Okay? Simple enough? Is this helping more?
Yes.
Make a lot more sense?
Give us a test.
Shut up, Jeff.
Not yet. Check. Okay. Then let's say you had something like $1,028 times 16. So I'll go ahead and give it to you. 16,448 is the number. But you have to determine how many sig figs should I actually have in my final answer.
You round to the lowest number.
So, which one? How many sig figs are here?
4.
How many are here?
2.
So I should be,
2. So it's 2.
so it's just 16,000. You can see why I hate sig figs. I feel like it doesn't make it very accurate or precise. But we stick with it.
Why do they do this?
Because they're saying it's gonna make, it makes you more accurate and precise.
So,
A bunch of people with PhDs in science say we have to do this, so I go, okay, we do it. All right, so what about, how many sig figs?
should we do that for
First one has two, doesn't it? Guess it's the way you know.
Yes. First one has 2 sig figs, just the 4 and the 6. The second one has 4 sig figs. So ultimately, you'll be left with how many sig figs?
Two.
2. So, hang on. All right, so if you do this, you get 9.2184 times 10 to the negative 5th. But I'm only supposed to have how many sig figs? 2, so it's just 9.2 times 10 to the negative 5th. Okay?
Is yours the best thing
This absolutely is the stupidest thing you've ever done. You can absolutely see why I did not teach it in regular Chem. But now it matters. Okay? How do y'all feel with this? Everybody good?
I need a second to write this down.
Okay. Well, while you write it down, I'm gonna go ahead, I gotta give you 2 things, okay? One, this is the thing that I told you was the homework. This is just on sig figs, to make sure you're good with it. You're not gonna work on it right now. You're gonna work on material. Because today, your best friends come back, which brings me to the second thing I have to give you. Do not freak out. You're more familiar with the periodic table than what you actually think. But in this class, we're not using the periodic table we used last year. The reason for this is AP Chemistry has a periodic table they give you on your test. So I want you familiar with their periodic table. And you can see why I did not use theirs in regular Chem. There's no names, there's just the symbols. You guys are already familiar with it, so naturally. So the piece of information that you can find on here is the chemical symbol and the atomic number and the average atomic mass. There's a reason I gave you this. Starting in AP Chem, now I will tell you, you're going to see me, I have to split some. I am going to have to use like a PowerPoint some, and the reason for that, there are graphs and things that I just can't waste the time to put them on the board. So I will have a PowerPoint, but we're going to go through topics 1.1 and 1.3. If you look on the schedule, that's where we're heading, that's where we're going. You're going to love this because you're more familiar with this than you're aware. Riley, you good?
Yeah.
Cool. Let's start in on topic 1.1. 1.1 will be very familiar and you'll have no issues. Calculate the mass of mole sample of barium hydroxide. Now per se, because somebody asked me, is this problem, Bob? No. Is it a little challenging? Yeah, you've had to summer off. I'm going to work through it with you, okay? So you don't freak out on me here.
Yeah, I was about to say, I'm done.
I know that, but you're looking at a mobile conversion. So remember with this, you're going to make a plan. Figure out where I'm starting. Where do you know, how do you know where you're starting at? Look at your number, look at the unit. I'm starting at mole. Now determine where we're going to go. Well, what am I asking you to find?
Mass.
I'm asking you to find mass. So that is going to be grams. With all that information being given to you, if I gave you enough time, I know I'm moving fast. Everybody get it wrote down. Okay, so we have 0.421 moles of the barium hydroxide. Now, here's the fun part. Set it over 1. The only thing that changes for you now compared to what you had before, how many sig figs should you have in your final answer? How many sig figs did you start with?
3.
There was 3. 1, 2, 3. Those 3 are significant. So I do all the math, and at the very end, I leave it to 3 sig figs. So we set it up. Where am I going to? Grams. Barium hydroxide goes on the top. Moles of barium hydroxide goes on the bottom. Yeah, absolutely. Go for it.
You want to swap it out first and see if we get it?
Yeah, go for it. Because it'll be good. This is, the trick is I gave you this molecular formula on purpose. So I wanted to check something.
It's okay. I didn't even get myself one.
No, that's funny. You really will find out on this answer why they're not my secret.
Thought the atomic mass for hydrogen was 1.0.
Welcome to AP Chem. More accurate, more precise.
We're done.
I get you.
They use this in college because it's next year.
Yeah.
They have like huge periodic tables in their
You get it?
Shut up.
What else we got?
So how much time are we getting on the AP exam?
That I can't think off the top of my head, but I will look at it and tell you.
I hope it's 2 hours long.
I can't think of how long the free response is. I do have good news for you though. It's going to be a morning test at 8 a.m., which means me and Mary will be making you breakfast and coffee.
Really?
Oh,
Can I have tea?
We have brisket.
I don't drink coffee.
I'll make you.
Yeah, I don't drink coffee either. I
You want tea?
love coffee. I like tea.
Can we
I make a lot of
can we have
coffee.
pork belly?
We'll take care of it. For breakfast, I don't know about that, Jody.
That
If you hate us, just say that.
AP treatment.
Just don't suck.
Okay, well, you see, I got through that part, and now I'm gonna have problems with sig fig. Because you're adding it, but when you add it, oh wait, is that only if you're adding the
What are you even talking about? Like, you're
What
just
mathematical property did you do here?
add? So you gotta round past the.
What mathematical property are you doing here?
Oh,
Don't apply the sig figs here.
oh, okay.
Don't apply sig figs here. Apply sig figs at the final answer.
Okay, when you say lowest number of sig figs, is it the lowest number in the 3 sig figs or lowest number of sig figs?
That you start with. So when you started with this is the only number you start with. There's 3 sig figs. You have 3 sig figs in the final answer. What you guys are going to see later on, and here there's like mathematical formulas and stuff you work through that you have multiple pieces of information has to be given, and you use the lowest number. Like last year on the AP Chem exam, they tricked a lot of people because when they did They did a problem that had a change in temperature, and there was only one sig fig in the change in temperature if you did it properly, which meant your final answer should have one sig fig. I mean, it was really cruel, but I mean, it was mean.
So, because everything has to be in sig figs in the AP Chem.
Yes. They will give you grace on all the problems of one sig fig value. So if you added an extra one or you took away an extra one, except for one problem they choose, and if you do not have the proper sig figs, you don't get the point.
So, would it just be 72?
There you go.
Yay! I'm surprised I actually
Oh my
wrote
goodness, I
it.
got it right.
Now, I do want to bring your attention to this, okay? Just because I'm trying to lay groundwork for you to be successful on the test. They don't necessarily, you don't have to write that part out. Hello?
Will you send Tyler to the counseling office, please?
Yes, she's on her way.
Thank you.
Welcome. You don't have to put the barium hydroxide part, they're not so necessarily caught up on that, but what they do want to see is, what's up, girl?
They want me to ask you if you have some clear boxing tape. The most random thing they could send me for.
I do both.
What are you switching for?
It says Unicode. Yes.
Why is it like 50 degrees this morning?
It's supposed to be cold like that always.
I'll tell them and I'll check mine, it's no big deal. We're trying to hang up some name tags.
No, I got you.
We're out of tags. Well, you know, Kevin, go ask Kevin. I was like, okay.
All right, so here's the thing. Barium hydroxide doesn't have to be there, but you're already used to this part. Grams has to be there. If you do not have grams, they're not going to give it to you. They said the only way they'll give it to you is if they asked it in the question. If you just wrote the number down, they just look and say, you're assuming that the person reading it knows that that's what you were looking for. Don't assume that. Put the unit. This will suck.
So hypothetically,
No,
say that on 72.1,
Wait,
say
so how-
that wasn't a 3, say that was like a 5, would you round to?
Yes, 72.2.
So how would you write that on like the, would you just, like, would you type it in?
What I type in?
Like on?
I typed in
No,
to get this.
No, how
free
would you
response,
type,
how
like
would you
on
type the
AP
answer?
Chemical, like exam?
I did
No, I
0.421.
meant
The answer.
Time.
the answer, like how would you?
How would you type the answer?
Who
on
makes
free
how do you
response?
put the units?
You literally will write it. You're not going to type. Here's the thing, and I'll hit this beforehand. You will not type the multiple choices on it, but then the free response is actual paper.
Oh.
Oh,
You actually will fill it in. And there was an issue this year, a massive issue, and they did not say they're going to correct it in the directions. So I'll go ahead and hit this out the gate. Whenever you go into the multiple choice, in the prompt, it tells the proctor to tell you, you are not allowed to write in the free response question book. Which is stupid. You shouldn't have the free response question book yet. But they have to give it to you. The prompt's messed up. They give it to you, and they tell you not to write in it. So then when it came to the free response question section, proctors thought kids weren't supposed to write in the books. So at the AP Chem reading, they have tons of blank free response books because kids didn't write them. They did it all on scratch. It has to be in the free response book, okay? So whenever it comes to the free response question at the very end, you actually write it in the book.
We will get paper and calculators and stuff, right?
Yes, you're allowed to have it, and I want to say they said on the multiple choice one, like you have Desmos. I want to say you have Desmos, but you're allowed these as well.
I'd rather use these.
These are a whole other.
I will make sure and provide them. I will have to look to make sure they hadn't changed the rules, but I will look all this up and let you know. Okay? So, mole conversions. Everybody get this number though?
yeah.
Everybody get that right? Because that's the one that I was worried about you would mess up, that you would forget that 2 goes for the oxygen and the hydrogen.
I did forget that at first. I had to read my head.
It's all good, you caught it, okay?
I swear last year gave me so much drama, like, I'm not gonna lie, like, before school ended, even before,
What are you talking about?
can you oh my, what are you on about there? Like, what are you talking about?
It's kind of like, you don't have to drop it, 'cause if you don't drop it, you're gonna be in the top 5, which is not true.
But, no, like, this class gave me so much, like, PTSD from last year. Like, after Chem, we took our final and stuff, like, I was texting Renee, like, 2 o'clock in the morning, I was like, what? I was just, like, asking about random students. What was I asking you, Ren? Like, after,
So
we
they
took
just
our
called
final, I
off
was like,
seniors
wait.
and
Well, it's not about trees.
No, I was like, tweaking out.
Joe just messaged me like 2 a.m. on school
I
night.
was like, what time to leave?
Jody, you make me nervous because
Miranda Osborne to the counseling office, please.
you freak yourself out.
And Chloe Carlin. Miranda to
You
the office,
constantly push
please.
yourself and freak yourself, you get in your own head. And I'm like, you just need to chill out. All right, I want you to calculate the mass of,
Calculate the mass of
This idiot.
molecules of ozone. Okay. If you can do this one, I'm convinced you can go forward to back, back to forward.
times 24. 24th to 23rd. 10 to the 20.
So I think it's what,
6.022 times 10 to the 23rd, which I have good news for you. That's what they give you on the MP exam.
our numbers.
They give you that concept.
The E counts for the 10, right?
Yeah.
Times 10.
That's the final answer, isn't it?
If you're still calculating, that's fine. Finish out. Anybody not get this?
I forgot the second.
I didn't.
I forgot how to go from molecules to mass.
Okay. That's okay.
I forgot what avocado guys were.
So when you do this, the setup,
Oh.
You take the 4.32 times 10 to the 24 molecules.
Oh, I did the 5. That was
Set number 1. Then we're going to go to moles. I want 1 mole of ozone on the top, and then it's 6.022 times 10 to the 23rd molecules on the bottom. And then you go to grams of ozone on the top, mole of ozone on the bottom. And when we do this, you calculate the molecular mass of ozone, you get 48.
See, the only part I struggled on is I could not remember the number. I had to go look back in my binder from last year to see what the number was for it.
It's okay. That's fine. This number is given to you on the exam. But if you have to remember, you don't have to do for it. Then you're good. So we'll take the 4.32 times 10 to the 24, divide that by 6.022 times 10 to the 23rd, that's 23, and then multiply by 48. And if you get this, you get 344 point something. But how many sig figs? 3.
Like Gowan.
So it's 344. Okay? How y'all feel with those? Nice reminder, right? Remember stoichiometry? Comes back in unit 4. So some people will jump from unit 1, go straight to unit 4, and then go back. But I'm gonna wait. Okay?
I think we need a refresh on stoichiometry.
We'll get it.
Are you putting your binder up?
Huh? I was just checking, I was looking at that.
All right, so there's a reason I'm doing this now, okay? So now that was topic 1.1, moles and molar mass. Now I gotta go to 1.2, which is mass spectra of elements. That sounds very fancy. You're already familiar with it, just not in this representation. So whenever we look, this is, don't worry about any of that. I ain't gonna read that stuff to you. This,
Percent abundance.
it's just percent abundance. But it's in a graph form now. So when you look at this, you have the atomic mass on the x-axis, percent abundance on the y. So if you look, we're dealing with chlorine. Chlorine has 2 isotopes. There's chlorine 35 and chlorine 37. 35, 37. So when we look at this, we have the percent abundances that are given with it. Now, you can be asked to do multiple things with this. One, they can ask you calculate the average atomic mass for chlorine. Other things they can ask you to do, they can ask you to estimate which isotope it would be closer to. So which isotope do you think it's going to be, the actual average atomic mass will be sitting closer to? Chlorine 35 or chlorine 37? 35, why?
Oh, wait, it's because
75% of chlorine is chlorine 35. So a greater chunk of the average atomic mass is chlorine 35. So these are the things that you can be asked to do. Other things you can be asked to do is determine the number of protons, determine the number of neutrons. I know this seems very elementary to you, but yes, they're going to ask you to do this on the test. So, reminder on how to do this. I'll first want to start with the easy part. Let's look. I have chlorine 35. And chlorine 37.
Oh my god.
I know we're all gonna be tweaking today.
Why?
It's just gonna be you.
Now watch this.
I feel confident about this test. Like,
I really care.
No, I'm not. It's not like I don't feel confident. I know I'm just be tweaking stuff.
You're always.
Jody's gonna be at
Jody, you are
all
always tweaking.
night.
Like, let's be real.
Alright, first things first. How many protons are in chlorine 35? 17. How do you know that?
The atomic number.
Atomic number off the periodic table. This is why they'll ask you like this. This right here is simple points you can miss just because they're gonna trip you up. So don't get lost on that. How many protons are in chlorine? 37.
17.
It's both the same. The element's chlorine. It doesn't change. Remember, number of protons, each element has a fixed number. This is where we gotta figure out the number of neutrons. Remember what these numbers are. The 35 and 37 is what we call the mass number. The mass number is equal to the number of protons plus the number of neutrons. So we have the mass number, I have the number of protons, so if I want to find the number of neutrons out, it'll be equal to the mass number minus the number of protons. So you tell me how many neutrons I have in chlorine 35. How many neutrons are in chlorine 37? 18 and 20. Simple enough?
Yeah.
Not too bad. So then comes, how do you calculate average atomic mass? Whenever you're going to calculate the average atomic mass, remember it's the summation of the mass number from the isotope times the decimal of the percent abundance from it. So remember how I teach. I taught you last year to do this. You literally take the decimal and the percent abundance and move it 2 places to the left. So for chlorine 35, we have 0.758.
So would this be average atomic mass or percent abundance?
What?
What we're doing right now.
We're going to calculate the average atomic mass. And then,
0.242.
thank you.
So this is calculating atomic mass for a percent abundance.
This is calculating average atomic mass using the mass number of the isotopes and their percent abundances. You got to bring the mass number in with it. So we get 35 AMU times 0.758 plus 37 AMU times 0.242, which will be equal to I get 35.484. But
Sig figs.
don't worry on these.
Mackenzie Owens, the Kenyon Hanger, to the counseling office, please.
Don't worry about counting those two and saying you have 2 sig figs. On mass numbers and stuff like that, you ignore it. This is how we're going to determine the sig figs.
So treat that like a scientific notation.
So what should we have?
You should have 35.4.
35.5 AMU, which is just atomic mass unit, or we should have 35.5 grams per mole. Okay? What's your question, Ryan? Okay. While you're doing that, hey, I have news for you. Guess what was the first question on the free response question last year?
This.
Here's the thing that they had you do. They gave you the table with the information in it, and they wanted you to draw the graph for the line. So all you had to do was put a line on the paper, on the graph, to show how much should be left. Right? We will. If you, I just get that right here. hopefully it wasn't too bad. With you guys, it was actually kind of cool. I had a tutoring session online yesterday at 9, and someone was needing help with sig figs. I was like, yeah. So we got y'all there. Besides that, let's pick up where we left off. So we started looking at atomic mass spectra yesterday. So we looked at chlorine, for example, and different little values and things that we can pull from that. Pretty sure we calculated the average atomic mass of it, reminded you of that. A couple of things that can be asked of you on these is, one, you can be asked to calculate the average atomic mass. We can be asked to estimate where it's going to be. The other thing of it is the number of protons and neutrons. We did that also. How are you guys feeling with that? Good?
Yeah.
Okay. So I don't want to like beat a dead horse. Oh man. Come on, Kevin. Alright, so they can represent it to you in this form or fashion. So they could be asking you a question like to calculate the average atomic mass of an element, but they don't have to necessarily give you the chart like we had with the chlorine. They actually can just give you the graph. Why? Atomic mass, the AMU is there, so we have 121. So we have one that is 121 atomic mass units, multiplying that by the decimal of the percentage. So if you look on the graph, we have 57.4%. So we'll multiply this by 0.574. And we'll add with that, we have our second isotope is 123 atomic mass units, and we'll multiply that by 0.426. Multiply them together. Then we'll get 121.852. Give you a second, make sure you guys get that. Everybody good? Okay. Yes. Yes. So in this case, you're going to round it up to San Pacific. Technically, you should do 3 because we started you with 3, but these are also constants, and we would want a little more. If you gave me 122, okay, but this is probably going to be like a multiple choice for you. So you really want a decimal place here, where it's the average atomic mass. I'm going to go 121.9 AMUs.
So if we're answering 122, then it says will be correct.
Yes. But the reality of it is like in this case, if they asked you to solve this, you're technically one place, one more sig fig, so that way you lose a point on free response as if it was the significant figure question. Or reality of it is they probably could throw something like this at you at a multiple choice section and have you solve it real quick.
So if it was like 122 or 121, we'd always pick 120. We'd always pick that with the decimal.
For average atomic mass, you're going to want decimal.
Okay.
All right. So in this case, something you can do is kind of estimate what element they could ask you to estimate what element you think this would be. So you would want to look for something around that. So something around 121.9. And you're just going to look at those average atomic masses they got listed on there. I'm going to try and save you some time. And you're going to look right down there, find yourself looking down around 49, 50, 51, 52. And you will see antimony has an average atomic mass of 121.76 AMU. So more than likely, this is antimony. And you can just assume. Okay. Questions of that? I know that's kind of simple, and I don't want to like bore you to death with it.
So I'm saying that there's like a number, it's like 0.009, how many 6 figs would be 3 or 4?
0.009?
Yeah. So the zeros before it don't count.
Correct. Leading zeros never count. So is everybody good here? Okay, I know this is boring. All right, so let's give you something new. Now, this is something you haven't done before, but is a very important piece. It uses skills you've already developed. But you have to be able to do this because of empirical molecular formulas, which is where we will go next. But what we're going to do is called something as we're going to calculate. Oh my gosh. It is Wednesday. What we're going to do is calculate the percent composition. What percent composition is the percentage of the elements that make up the compound. So what you're going to do with this is, let's do one, and then I'll explain. Let's do it that way. So let's say we want to find the percent abundance and percent composition. Sorry, not abundance of glucose. So glucose is C6H12O6. So there's your molecule. So what this is we want to find out what percent of glucose is carbon, what percent is hydrogen, and what percent is oxygen. In order to do this, we have to use the molecular mass or the molar mass. They're interchangeable. So we use molecular mass of the molecule. You will take the mass that is coming from carbon and divide it by the whole. So with the carbon, you'll do exactly like you've always done to find the molecular mass of it. So with carbon, how many carbons I got? 6. How many hydrogens? 12. How many oxygens? You will multiply them by the average atomic masses off the periodic table. Now, this is the one they're going to expect you to be using. So make sure and use this form, not the other one. So if you look at carbon, carbon's average atomic mass is 12.01 AMUs. Hydrogen is 1.008 AMU. And then oxygen is 16.00 AMU. You're going to throw these all out because you're actually going to need these individual numbers. So we get 72.06 AMU. AMU. 12.096 AMU, and then I get 96 AMU. Now you're going to add all those together. And we get the average ton, we get the molar mass of glucose, sorry, to be 180.156. These are the pieces of information we need in order for us to solve and figure out what the percent composition of these things are. So what you will do with these is you will take the molar mass from the carbon and divide it by the molar mass of the whole. The molar mass from the hydrogen, divide it by the whole. Molar mass of the oxygen and divide it by the whole. This will give us our percent composition. So we'll divide all these by 180.156 AMUs. 180.156 AMUs. We'll multiply by 100, let's start now, points. I'm just gonna round to 40. Then we got, so I get 6.71%. Oh, that should be it. I rounded wrong. Sorry.
No excuses.
I'm a big excuse maker today. I'm sorry. All right, so you break this down, you look at this. This is what we're saying. 40% of glucose is carbon. 6.71% is hydrogen. And then 53.29% is oxygen.
So we don't round it to the whole number?
No.
Do we do 60?
You want some of that? It's kind of going to be hard to do the sig figs on this one because you're pulling constants and values. I get the confusion with the sig figs.
So when do we use and not use sig figs? I mean,
You'll use it with calculations when you're adding, subtracting, dividing, and multiplying.
not on percent.
But not with
Percentages.
numbers that are like constants that were given to you. So
So the first number is constant number.
this is why I don't like sig figs, because we have to teach you sig figs, and then it's like we're not really applying the sig figs yet until later on. You get a feel for it. I won't kill you on it, but here just round 2 places past the desk. Okay. Everybody get how I calculate the percent composition for this. Okay. So I want you to try calculating the percent composition, and I'm going to I'll give you 2 minutes. I don't think you need longer than that. Okay, but do it for it's ethyrose C4 H8. That's O4. Yep. You guys give that a shot and see if you can get it, because I know this one's new. Hey Siri, start a timer for 2 minutes. Hey Siri, start a timer for 2 minutes.
Tyler Stewart and Molly Meadows to the counseling office, please.
This is something you still calculating. If you are, finish it. Don't freak out. It is the same.
Yeah. That's what I was realizing as I was doing
I
that.
gave you the same on purpose. Because I want to lead us into empirical molecular formulas with this. So what you're gonna see with this is you get 40% carbon. You get 6.71% hydrogen. And we get 53.29% oxygen. So, there are two different types of chemical formulas we talk about in chemistry. There's the empirical formula, and then there's the molecular formula. You guys have dealt with molecular formulas. I didn't do empirical formulas, but we got to now, so that you're prepared. So when we break this down, the empirical formula is the most simplistic ratio possible. So what I'm saying with this, if I look here, we're going to apply some algebra skills. You can factor out numbers here. So if you look, 6, 12, and 6, I can take a 6 out of each one of these. So it's like we're going to factor a 6 out. So what I end up with is, what's 6 divided by 6?
1.
So nothing there. Then I have hydrogen. What's 12 divided by 6 is 2. And what's 6 divided by 6 is 1. That here is the empirical formula. What you have over here in the black, this is the molecular formula. It'll be the same thing here. If you factor this one out, we're not factoring a 6, we're actually going to factor out a 4. And we'll get CH2O. This is why your percentages are matching. The empirical formulas between the two are exactly the same. They're not changing. On the flip side of this, I can give you percent compositions, and they can do this on the AP test. They can give you percent composition and have you calculate the empirical formula. I want to show you how to calculate empirical formulas. So this is all going to be how we calculate them. There it is. So if we're going to calculate the empirical formulas from something, what you're going to have to be given, you have to find yourself with a percent composition. So in this case, I would give you information that there's some molecule and 40% is carbon, 6.71% is hydrogen, and then I would say 53.29% is oxygen. So you have the percent composition of it. That's fixed and you know it. What you have to do with it now is the most simplistic thing. You assume 100 gram sample. Why in the world are you going to assume 100 gram sample? If I have 100 gram sample, what mass of carbon do I have? 40 grams. What mass of hydrogen? 6.71 grams. 53.29 grams of oxygen. You now assume the 100 grams so that we can flip the percentage sign into grams. Got me? So here's what we do. And you're going to see why I said this is using a skill you've already developed and gained. You now have to calculate the moles. So we want the moles of carbon, the moles of hydrogen, the moles of oxygen. So it's 40 grams of carbon over 1, 6.71 grams of hydrogen over 1, and it's 53.29 grams of oxygen over 1. To do this, we want the moles, so we have to do the conversion factor. We have to use the average atomic mass off the periodic table for each one of our elements. Remember, we're going 2 moles, so moles is going to go on the top, so I have 1 mole of carbon on the top, 1 mole of hydrogen on the top, and 1 mole of oxygen on the top. Do not fall for the trap. This is not a diatomic. It's not by itself right now. Not a diatomic. It's not by itself right now. Do not double the value off the periodic table. Okay? I know last year I tricked you like crazy with the diatomics. Remember, diatomics only exist in nature belonging to themselves when they're by themselves. So for carbon, it's 12.01 grams. For hydrogen, 1.008 grams. And for oxygen, 16.00 grams of oxygen. Throw this calculator. Get 3.33 moles. 6.71. I get 6.66 moles. And I get 3.33 moles. So this is the moles of carbon, moles of hydrogen, and my moles of oxygen. Reason you did this is we're now going to find a ratio between them. Once you get to this point, you choose the lowest number of moles and you divide all of them by that. You're going to find the coefficient here. So in this case, I got 3.33 moles of carbon and 3.33 moles of oxygen. These are the smallest and it's the lowest number. That should make sense because if you look back at the empirical formula, the coefficients are the same for carbon and for oxygen. So then what we do, we divide it by that number, so 3.33 divided by 3.33. You are dividing by moles. Divided by 3.33 moles. You do this, what do we get for carbon? 1. Hydrogen is 2. Oxygen is 1. Those are the numbers to tell you how many of that element is present in that molecule. Okay? That gives you the empirical formula. So from here, we can build it out and see that we have CH2O. That's how you calculate the empirical formula. Molecular formulas, you do the same exact thing. You have to calculate the empirical formula, and then the other piece of information that will be given to you is you will actually have the molecular mass. So what you will have to do then is you will take the molecular mass that's given to you and divide it by the molecular mass from the empirical formula. So, I really wish I had those boards like I got in college. I can just slide up. I really don't want to erase anything. I'll do molecular formula here, great. So I will not give you the actual molecular formula. They won't give you the actual molecular formula. They will tell you the molar mass or molecular mass of the molecule is 180.156 AMU. And they'll give you the information. They'll tell you that the percent composition for the molecule is 40% carbon, 6.71% hydrogen, and then it's 53.29% oxygen. Then what you have to go through is you have to calculate the empirical formula. We just did it. Once you have the empirical formula, you then have to find the molar mass of the empirical formula. So in that case, I don't think I did it.
Josiah Fowler and Jacob Mullins to the counseling office, please.
I get 30.026 AMU. Then what we're going to try and do is what you want to find is you want to find the multiplier in this case. So to find that multiplier,
The molar mass is the molecular mass, right?
what I have to do is, because these words are interchangeable, the big thing on the AP chemistry test is vocabulary. They're going to use all the terms and all the vocabulary. So if you're not familiar with the terms, whenever you get there, it's going to freak you out and you're going to trip yourself out. Because there's certain people that get all up in their heads and all emotional and all built up and stressed out, and they don't need to.
Just say my name.
Kenley?
I'm confused. How did you get 30.3 out of?
So I did carbon, hydrogen, oxygen. I had 1 carbon, 2 hydrogens, 1 oxygen. Multiplied it by the 12.01 AMU. Multiplied by the 1.008 AMU. Multiplied by the 16.00 AMU. And then I added those together. Now all you have to do, take the molecule, molar mass, divide it by the empirical molar mass. When you do this, you'll get 180.156 AMU, and we'll divide that by 30.026 AMU. And you do that, you should get 6. Yeah, you get 6 perfect. So that's the multiplier. So what that tells you is you will take that and distribute that into the empirical formula. So now we'll multiply. So 6 times 1 is 6. 6 times 2 is 12. 6 times 1 is 6. That is the molecular formula. I could have done the same thing for you here on this one. I could have gave you the empirical formula, the percent composition, and then gave you the molecular mass and asked you to find the molecular formula for that. The key to this is if you're going to calculate the molecular formula from an empirical formula, I have to give you the molar mass of the molecule. If that's not given to you, you can't solve for it. Got me?
Mm-hmm.
You guys okay? Okay. So, they can be some tricky ones. So I want to give you one that'll be a little tricky that you just add a little step to. Are there any questions I should ask? Anything at all?
Did you round to the 6 or was that just 6?
It was a 6 straight
It's
out.
perfect 6
Oh,
in my calculator.
It's perfect 4 for the other one.
Nice. Our math is mathing. So here's a big takeaway, okay? I need you, I want to make sure you can calculate percent composition for some elements. I want to make sure you can calculate the empirical formula, and I want to make sure you can calculate the molecular formulas. Are y'all just done because it's first period?
No, there's like 3 new steps, 3 new things we have.
I'm just hungry.
I'm cold.
Maybe that one.
I do agree. I do feel like it's colder.
I already turned it up.
Just turn it all the way up.
Before you even got nervous.
Okay, I get that it's a lot. I promise you, I'm throwing a lot at you right now because this is easy compared to the stuff that's hard towards the end, so that we have all the time we can at the end, especially with the acids and bases, because they're going to hammer you with them. So,
So will that be a question? ACT? Or?
ACT.
no, they won't ask you that. Can this be a question on AP chemistry exam? Absolutely.
Would it be free response or would it be
They could give it to you either way. So the multiple choice one, they probably wouldn't, but I absolutely could see this being a free response. Because here's the thing with the free response, it's just a mix of everything. I mean, they're gonna ask you, anything's fair game on that thing.
So they should have to say that's the molecular mass and those are percentages and bigger.
They can make it more wordy. Like, I'll give you practice problems. So that end of the unit packet, I'm gonna have examples like that in there. Like, I actually will take questions from old exams and from old practice exams and throw them on there so you guys are familiar with them, because what I want is you to be familiar with it. All right, I want you to calculate the empirical formula for a compound that has 43.64% phosphorus, and let's do 56.36% oxygen. You want to give it a shot? You want me to roll through it?
So
Oh, that's a
The
5.
empirical formula is dependent on the molecular formula.
Is that a 5 or an S?
Yeah, I thought that was an S at first. It took me a second. It really did look like an S.
No, I knew it was a 5. I was like, give me a hard time.
It's an empirical, right?
Mm-hmm.
Do you have a molecular mass, a molar mass? Since you don't have a molar mass, you can't calculate the molecular formula from it.
Tires help.
Completed, give it to, please make sure to put your name on it. I know that one I did not actually get a name thing put on it. I apologize. One I got for you today, we'll have one.
It does have a name tag.
Yeah, I'm really not gonna be turning mine in until.
Does? Mine did not say right. Well, that's fine. Listen, you have plenty of time to
There's
get
a
that,
second
guys.
paper on that.
I keep forgetting that I have to do it.
The whole purpose of this is literally just getting it in front of you guys.
Sir, I don't know what I did, so.
It's okay.
You should go over number 1.
What is it?
I said you should go over number 1. I keep telling myself that I was gonna do
Okay,
that.
so,
I probably just 16 over whatever number and then you find out how much of that sample is oxygen.
I can't, because we'll start this now, we're gonna keep this going, and the homework, we got harder, I'm gonna make a video, you come see me some other time, and I will absolutely go over it with you.
When you're planning,
7.
breaks like a fan.
You can see me during lunch. Okay, so I give you this information up here on the board. So yesterday we focused in on percent composition, applying this percent composition, finding empirical formulas, finding molecular formulas, and I feel like we're doing good with the empirical molecular formulas. But now the thing that I want to focus in on is us getting formulas correct, because there's a second way you can calculate the formula of something from some data. It kind of is a little different, but I wanted to take time, slow it down a little bit, and make sure you get this, because this is another form that they can ask you to do and has came up before. So they can give you a table with some data in it. So there is some mass of a sample that's burned completely up in oxygen that had a mass of 5 grams. Then they have the mass of the carbon dioxide and the mass of the water produced. So you guys, since you had chemistry, know that this is a combustion reaction and it produced carbon dioxide and water. We went completely through, there's nothing left over, and this is our product. So now what we're trying to figure out is some different questions that can be pertained around this. So the information you have is that table, and it says a sample that contains carbon, hydrogen, and oxygen is burned completely in O2. This is a good example of what a free response question could look like. They can give you that information, tell you that, and then ask multiple questions on this. So the first question I want to look at, sorry, I'm tired. I haven't got back in the swing of it yet.
Get to it.
And Hannah just does not understand that I'm getting up at 5:30. She gets up when she wants.
I think she can like comprehend what 5:30 is.
Thanks, Jody.
No, because like I didn't gain consciousness when I was like,
You didn't
Yeah, I
gain
was-
consciousness until last year. So you shut up.
I didn't gain consciousness until I was like 4 years old. Like I don't remember anything before I was 4.
Lucky, mine was 6.
Okay. Hey.
Did you not have that when you was a kid?
Oh my God. Just continue.
I was born with it.
Yeah.
No, Jody, I did.
Yeah, he was actually doing chemistry problems when he came out the way.
All right, so A. Part A is question A on this one is going to determine the mass of carbon present in the 5 gram of the compound. So we want to determine the mass of carbon
Oh,
I can't.
in the 5 gram Now, I know you guys remember last year so nicely, especially at the end of the year, that your first instinct is going to be for you to just like, oh, this is just stoichiometry.
No.
No, it's not.
I forgot it, so.
Well, it's
Oh,
okay.
what?
It's okay. Okay. The reason this is not stoichiometry is we have no idea what the chemical formula of this sample is. Since we don't know what the chemical formula of this sample is, we can't do stoichiometry because we can't do a balanced chemical equation. So there has to be another way to solve this. This is how you have to look at AP chemistry on that AP Chem exam. You have a toolbox and there's going to be tons of tools in it. This is just another tool for you to use. So when we look at doing this, what information have we been given? We had a sample that has carbon, hydrogen, and oxygen in it, and it's been completely burned up. Where did all the carbon from the reactant go? Give me the chemical formula. Where'd it go? What products you got? Carbon dioxide and water. Where did all the carbon go? It went to the carbon dioxide. This carbon came from this sample. That's where it all came from. So the key to us on A is using this piece of information that's been given to us here. Because we know all the carbon that was in that sample has been used there, so now we get to use that piece of information. Understand where my logic's coming from. Okay. So you know, because I had two people shake their heads now. You know in a combustion reaction you have a hydrocarbon, oxygen, heat. It produces carbon dioxide and water. Where did the carbon in the carbon dioxide come from? From the hydrocarbon. Okay, so if I completely burn that hydrocarbon up, is there any of my reactant left? No. So you can't just disappear. The carbon just doesn't disappear. The carbon's got to go somewhere. Where's the carbon go? Into the carbon dioxide. So it's like this. I'm not saying this is the chemical formula what we're looking at, okay? But let's say so this is the way to look at this, because you have to understand what's happening in reactions. Okay, on the simplistic level, I take this and I break all the bonds apart. Once I break all the bonds apart, they turn into this. That's like the most simplistic understanding I can give you for what a reaction's doing. So all of this carbon in this molecule is no longer here, it's over here now. The carbon had to go somewhere. The carbon just didn't disappear, it's in the carbon dioxide. Got me now? So the key to this, for us to be able to do this calculation and figure this out properly, is we have to look at the carbon dioxide, because we know all the carbon from the sample is sitting in here. So if we're going to determine the mass of the carbon, we'll start with just the mass of the carbon dioxide. Now here's the fun part. This really checks your knowledge behind what you're looking at. Because you're going to kind of do a stoichiometric calculation without doing a stoichiometric calculation how you're used to it. I'm going to set this up and we got to get to moles. So I want 1 mole of carbon dioxide. I want to leave grams of carbon dioxide, and I will give you that the molecular mass or the molar mass of carbon dioxide to be 44.01 grams per mole. I'm just going to give you that. I absolutely believe in your ability to solve and get that, but there's no point in wasting the time. You should be able to do that at this point. Now, we're going to use that piece of information, so the 44.01 grams carbon dioxide goes there in the bottom. But then here's the way of looking at this. If I have 1 mole of carbon dioxide, so in 1 mole of that carbon dioxide, I can break that into parts. What's making up the mole of carbon dioxide? In every carbon dioxide, there is 1 carbon and 2 oxygens. So when we're saying 1 mole of carbon dioxide, we're saying that molecule, I also have 1 mole of carbon because there's a 1. I have 2 moles of the oxygen. So I could use that identity and do the mole conversion here to where I look and I say 1 mole of carbon. And I'm leaving 1 mole of carbon dioxide. Where in the world did I get this from? That's just, again, an identity of breaking down of what I know of molecular levels. Inside carbon dioxide, in 1 mole of it, I have 6.022 times 10 to the 23rd molecules of carbon dioxide. In those 6.022 times 10 to the 23rd molecules of carbon dioxide, every one of them has 1 carbon. Since I know I have 1 carbon per that molecule, it's the same thing. I have 6.022 times 10 to the 23rd atoms of carbon present. I'm getting a bunch of looks, and I don't know if it's because it's like 7 a.m. in the morning or if it's like,
So,
where did this come from?
like, if it was not carbon dioxide and it was like C2O2, would you have 2 carbon per?
Yes. Because what happens?
You added a
I'm saying in that case, if I have 1 mole of C2O2, if I have 1 mole of that, that means I have 6.022 times 10 to the 23rd molecules of C2O2. How many atoms of carbon are in each molecule of C2O2? 2. So in this case, I don't have 6.022 times 10 to the 23rd atoms of carbon. I have 6.022 times 10 to the 23rd times 2.
So instead, like if you were using that, you would write 2 mole carbon right there.
Exactly. Okay. Let's look at it this way. You guys are used to you. There's carbon dioxide. That's 1 molecule of carbon dioxide. In 1 molecule of carbon dioxide, how many carbon atoms are there?
1.
There's 1. Got me? So there's 1 carbon atom in 1 molecule. So I have 1 carbon per 1 CO2 molecule.
Okay, I get that part.
Okay? I'm looking at you and telling you, I have here, I'm using that identity. Because what I'm looking and saying is, I have in 6.022 times 10 to the 23rd molecules of CO2. That's how many molecules I'm telling you I have. Okay, I don't want to use that. What am I trying to find? I'm trying to find carbon. So I have to find a relationship here. Well, look here. Molecules of carbon dioxide. Well, how many atoms of carbon do I have per molecule? there's 1. So this is interchangeable. I feel like all of you are looking, like most of you are looking at me right now like, I don't believe you.
I kind of get it, but like I don't.
It's just like, I get some part, I get like the, how many carbons in each, but like,
Okay,
a lot of it is just kind of gibberish.
you ordered a bunch of pizzas. We're back to the pizzas.
Good. I need the pizza right now.
Good, okay? You ordered the pizzas. On every pizza, there's 10 slices of pepperoni. You ordered 10 pizzas. But how many slices of pepperoni do you have?
And Emma Stewart to the counseling office.
Have 100 slices of pepperoni. Why? Because there's 10 slices per pizza. All you're doing is using relationships. I have to get you to understand and use relationships. If we can get you to understand the relationships and using them, I know you'll be successful on the AP chemistry exam.
So because there's like 10 pepperoni per pizza, it's 1 carbon per.
Exactly, because how many carbon atoms are there per carbon dioxide
Is that
molecule?
what you're asking? Like,
Yeah.
you could have said that. You're like, I think it's
Well,
looking,
he really has asked that. Like,
no, I thought you was looking for the grant, like how many,
that's what we're looking
We're
for.
getting there, but I'm getting you to
Oh.
understand where this identity is coming from. Because I'm pulling something you guys have never done before. This is one of those, you know how we've just sped through everything? It's so that I knew I'd have to hit the brake here today. I'm okay hitting the brake here for a moment, but I'm not like, we're not pulling the e-brake, okay? We're pulling a, you know, we're coming up to the stop sign, but we never truly really stopped.
How many concepts are we going to be doing?
Tons. Okay. Hopefully you get the idea where this is coming from. All I'm saying is in 1 mole of carbon dioxide, there's 1 mole of carbon atoms.
yeah, I get that.
That's what I'm saying.
Okay, if you would have said
You,
it
you,
yes,
would,
the
you didn't
first
have to
time,
bring the molecules and the atoms.
you
and-
said it like that, but you didn't say as simple as that.
I'll take the blame.
So that's basically like a mole ratio. You just try to find them.
That's
Yeah.
exactly what it is.
So you're just like replacing it from stoichiometry, instead of putting like the number that was in front of like the balancing, you're just putting how many you have of it?
Yes, because the balanced chemical equation is like mole ratios in terms of that reaction. But in this case, I'm using something internal. I don't have information for me to be able to do the stoichiometry with the balanced chemical equation, so what I have to do is the stoichiometry with the chemical formula.
Okay, so you're just replacing that to go ahead and change it to something else, and to do that, you're just using the number of carbons within the
Yeah, 'cause
series.
you- you're trying to find
Yeah, you
like.
could have explained that a little bit.
Just
Oh,
basically,
you're-
what
'cause you're-
number besides carbon is what you're going to put right there.
Yeah, because like.
Yeah, yeah, you literally could just say like the amount of carbons.
All right, I apologize. Happy everybody got it now. All right, so now I'm in moles of carbon, but what am I looking for?
Grams, so you just go.
I'm looking for the mass of the carbon, so I need the grams of carbon. And if you look on the periodic table, you have 12.01 grams of carbon, and that's going to be over 1 mole of carbon. You will see simple forms breaking this down easier. So if you jump, in this case, since this is a 1-to-1 ratio that's happening here, you actually could just jump to 10.99 grams of carbon dioxide times 12.0 grams of carbon over 44.01 grams of carbon dioxide. So, they put this in the
You
calculator.
made that way harder than that. I was like, where did the atoms and molecules come from?
Yeah.
Like I get why.
I get where you guys are coming from, that I made that harder than what it needed to be, but the other thing of it is you need to understand
Yeah,
that
the
concept
concept.
and that part, because that's the relationship we're using. It's not just a simple, this is not what I'm trying to teach you to do in this class. I'm not trying to teach you in this class that you see this problem, you follow these steps. What I'm doing in this class is I have to give you tools in your toolbox they don't tell you how to solve problems on the AP chemistry exam. They just tell you what they want, and you have to do it. Unless there are certain questions they use specific instruction on. Like in terms of Coulomb's law, then in that case, you best be talking Coulomb's law in your answer.
What is Coulomb's law?
We're not there. So I do this and I get 2.9, I need 5.02. That's 3 sig figs. But really, it'd be 3. So 3 grams of carbon.
I just don't understand vocabulary in this class. I think it's so pertinent. I don't know what load is like.
So could you like explain the relationship between like I get how to do it?
Well, I thought I explained it perfectly.
I don't know.
Okay, this is the relationship. You guys have to understand, really understand what moles are. Moles are just a conversion. It just takes really big numbers and makes them small and manageable. So when we're saying mole, it's like it's 6.022 times 10 to the 23rd. Atoms, molecules, particles, formula units. That clock's wrong.
Oh my God.
So whenever you look at that, we don't want to be dealing with. So I had a tutoring session 2 nights ago with a kid, and I literally looked at him and told him, would you want me to talk to you and say that I have 7.42 times 10 to the 24 molecules of carbon dioxide? Or would you want me to look at you and say, I have 2.3 moles of carbon dioxide? Which one's a lot more manageable for you to comprehend? What one is a lot more manageable for you to do mathematically? The smaller numbers are better for us. So what we're literally doing with it is the mole brings big numbers and makes them small for us. So inside this, you have to understand, when I'm saying 1 mole is something, that's 6.022 times 10 to the 23rd atoms, particles, formula units, molecules. In this case, that's 6.022 times 10 to the 23rd molecules of carbon dioxide. So in every molecule of carbon dioxide, how many atoms of carbon is there?
Yeah, you have 1 atom.
There's 1 atom. So that means there's 6.022 times 10 to the 23rd atoms of carbon present.
But it's not 6.
So,
how is it not like times 10 to the 23rd atoms?
because he's putting
It-
moles in the mole.
Exactly. It is 6.022
No,
times
that's
10
not.
to the
Like,
23rd.
so, because I know like in 1 mole of carbon dioxide, you have 6.022 times 10 to the 23rd, like carbon dioxide. But you said the moles of carbon only have 6.022 times. Did you say 10 times 10 to the 23rd?
Yes.
Okay, well, I got it now.
See, but you're proving my point. The mole makes it a lot more easier to understand. I mean, the truth of it is, you are getting lost in the fact that I'm saying 6.022 times 10 to the 23rd. You're like, what?
Yeah. So, like Miranda said, if it was C2O2, it'd be 2 moles.
Yeah, so here's going to be the point. Now we go to question B. B's different, okay? But no. You're doing the same thing, but it's going to show you what you're talking about in this case, okay? So that's the question to A. You're all going to have to keep me honest on something in here too. Do not let me circle answers. Because don't circle your answers. The reason for it is whenever they're reading at the AP chemistry exam, if you circle, and like let's say you circle it and you had an exponent there and your circle went through the exponent, they're like, man, I think they got a 2 there. I think they squared this, but I'm not really sure. And that's a big, huge debate. Do you give the kid a point or not give him the point?
Jasmine Day and Ella Powell to the counseling
Good
office,
morning.
please.
I'm awake. Been hearing you ramble on for like 8 years.
I'll be doing it forever. Pray for Mary. Okay, so B's going to be like the same process, but in this case, I'm not asking you to determine the mass of the carbon. I want you to determine the mass of hydrogen. So in the reaction, where did the hydrogen go?
It went to the water.
It went to the water. Now here's the thing, I'll give you the molecular mass of the water. 18.016 grams per mole is the molecular mass of the
Why
water.
we try this on our own?
Absolutely not.
I don't want to because I'm not confident that you guys are done with it yet. I have, on the homework I've created for you guys today, there's stuff like this, okay? So we're gonna start with the water, so we have 6.00 grams of the water. I set that over 1. Well, I gotta get this into moles of water. So it's 1 mole water on the top, and then I have 18.016 grams of water on the bottom. Now I'm in moles of water, but what am I really looking for?
Hydrogen, so would it be two?
So there would be.
So here's the key, okay? Look at the chemical formula, H2O. So in 1 molecule of water, how many hydrogen atoms are there?
Yeah, 2.
There's 2. So for every 1 mole
Yeah.
of molecules of water, there are 2 moles of hydrogen. So that's where we got 2 moles of hydrogen on the top. Got me? Okay, so it's 2 moles of hydrogen over 1 mole of the water. Click. I feel like it did. Then we set this thing up. Setting this up, we gotta find the mass of hydrogen. It's 1.008 grams of hydrogen, and that's over
Harley
a
McCoy,
mole
Colin Trent, and Brody Lester to the counseling office.
of hydrogen. So then we punch that in a calculator. What'd you guys get?
I got
Then 6 figs.
Yeah, that's right. She did right. 7-1. She went ahead and did it. So I have 0.671 grams of hydrogen.
What's that again?
What are you on?
Okay? Now, here comes the fun part.
I'm glad that was not in here.
Oh my god. How many mega is this?
Oh my god. Shut up. I hate those stupid videos.
What kind of mega version is this?
Now comes the fun part. You have a choice. C. I want you to determine the mass of oxygen in the sample. Now, do you want to be correct or do you want to be incorrect?
Correct.
See, there's 3 oxygens in it.
Don't lay bricks because you were laying bricks. Don't toss dough because you were tossing dough. Don't put pepperoni on the pizza because you just put pepperoni on the last pizza. Look at what's being asked of you and think
Oh,
the whole
sample.
thing through.
In the sample.
Massive oxygen in the sample.
Fine.
What was the other reactant in this chemical reaction? Oxygen. So not all of the oxygen that you're seeing, not all of that oxygen came from the sample. This is why the AP chemistry test is hard.
Is it in the sample, the oxygen
Because
varies.
you have some hydrocarbon that has carbon, hydrogen, and oxygen in it that reacted with oxygen. So all of these oxygen atoms you're seeing up here did not all come from here. So you cannot do what you just did.
And your lunch count. Thank you.
I think I did.
Yeah.
So you have to come up with another method. What you going to do? Because this is the part that's simple. Very simple.
I don't know. I feel like nothing is simple in chemistry.
determine the
So when
mass
it's
of
simple, I
oxygen.
feel like I get it wrong.
What makes up the sample? So look what you have. You have the sample mass of 5 grams. Carbon makes it up. Did you determine how much carbon's in the sample?
Yeah.
Hydrogen makes it up. Do you know how much hydrogen's in the sample?
So do you just
So
add
do you
those
add those
together
and
and subtract that?
So we will add the 3.0 and the 0.671, add those together and subtract that from 5. Is that simple? Yes. Why will tons of kids miss that on the AP exam? Because you will literally do what you just did, and the whole time you're going to be thinking, well, the oxygen had to come from this. No, it came from both. So you have to be careful.
So like when we add those with the sig figs, we'll just do 3.672 because you do the lowest.
Stop.
Let's see.
In this case, yeah, we would round it to that place there at the 2. So we would actually get the 1.33.
That'd be because of sig figs.
Yeah.
This isn't that hard.
It's not that hard. It's just a lot of things. You're starting to see. You're going to see here with like in the first month why I want so much review time with you. It's about putting tools in your toolbox, but then I have to get you, it's like you're a carpenter and you have all these tools. That's what you are. And I look at you and I say, here's the lumber, here's the drywall, here's all the stuff you need to build the house. The AP chemistry exam's the house. You have the toolbox in order to build it and conquer it, but we have to get you there to where you feel comfortable with it. Okay?
If you find out, like, whoever gets a 5, if we get a 5 on AP Chem, do we get like a special award or something?
It'll be over the summer, but I mean, sure, you get a 5, you can come to my mother's house and I'll make you a steak.
To the
Ow!
church and I'll be
You all right?
taking a pizza.
No!
I can make you a pizza.
I like closed my throat too early.
You sound like your lungs
What?
Went down to the level. Okay, now, let's bring this full circle. I want to ask you this. I would like you to determine the empirical formula of the compound. Oh my gosh! Remember what you gotta do. What do we gotta do with the empirical formula? You have the mass. You have the mass of the carbon. You have the mass of the hydrogen. And we have the mass of our oxygen. We get this into moles. So 1 mole carbon has equal to 0.01 grams of carbon. Hydrogen, 1 mole of hydrogen is 1.008 y'all's, I think. And then oxygen, I'm pretty sure, is 16 grams. So we break this down. I get 0.24. So that would be 250 moles. 671. 1.008. And 0.6 moles. And then 1.33 by 16. And 0.083. 1 moles. Then we're going to divide by the lowest one. So we'll divide by the oxygen. So we divide each of those by the 0.0831. So I get 3 for the carbon. I know you get like that decimal, but 3.00, that's 3. So 0.66. 8.01, that's 8. It's so close to 8. And then we get 1.
David Adams to the counseling office, please. David Adams.
So in this case, what do we get? We get 3 carbons, 8 hydrogens, and 1 oxygen. There's the empirical formula.
How'd you divide by the oxygens?
Because it's the lowest amount of moles. So divided out, that gives you the ratios.
And what we're doing then, counting the empirical formula with it?
You get them in the moles.
No, like
Oh, what word I ask you to find?
Yeah.
The empirical formula. Hey, that right there is kind of like what a free response question can be like.